Intro to vectors. So we just finished chapter or unit 8. There are like 4 sections of it. This one's supposed to be, it is 4 sections of this one. And then we're gonna take like a little mid test. And then the second one is gonna be matrix. So let's do intro to vectors. So what is a vector? All right, a vector is an object that has both a magnitude and a direction. So what's a good one that has a magnitude and a direction? Force. So like in physics, I don't know if you guys taking physics or took physics before. So the direction of something like a punch, it has how much force it has and in what direction. So vector is an object that has both a magnitude and a direction. All right, what else? A vector has a what? A vector has what? An initial position and an ending position. Is that what it is? An initial point and a final point? Terminal point? All right. A vector is represented by a ray. So a vector is represented by a ray. So what are examples of vector quantities in real life? Like I said, force. Is that my first example here? A force? Nope. Nope. Displacement. Displacement. Yeah. Displacement. You move from one spot to another. Velocity. Acceleration. Actually, these 3 are all connected. Displacement, velocity, acceleration. And my example I was talking about is force. All right, moving on. All right, so component form magnitude of vectors. Find the component form, the linear combination form, and the magnitude of the vector that is coming up right now. So, on a flat surface, let's say, you have an initial point and a terminal point. In the direction matters because, like I said, if this is the initial, then it's going that way. That would be the terminal. But if we go this way, then that other one is the initial, and this is terminal. So the direction matters. So let's say it's going up north or whatever. North. That's west. North. North. East. North. so it's going that way. Okay, so how can we know what are the component form linear combination for magnitude of the vector? You have to know what are the coordinates of the initial point. And you could say it on a graph, and then what are the points? What are the coordinates of the terminal point? Let's say that it starts at the origin, this particular vector, and then it goes. The tip of it is at 3, 4. All right. So component form of a vector, really it's kind of like slope. It's kind of rise over run. It's basically what it is. Subtract, but you got to write these little brackets to say that it is a vector. So it's like these little bracket things going like this, and you got another bracket going like this. What exactly is the name of it? I don't know. But these little, like, whatever, like this, they go like that. All right. So subtract the x's over subtract the y. Subtract the x's, comma, subtract the y's. So if you want to call this point 1, initial point, this point 1 will be x1, y1, then this is point 2. X2, Y2. Yeah, it's better. Little sub. We put a little P and little P sub 1. I don't. All right. So basically, subtract the x values. That'll be this. How much you've moved in the x and how much you moved in the y would be the other one. So the component form of the vector is going to be, and this is how you denote that it is a vector, v, and then put an arrow on top going. It always goes to the right no matter what. You always put an arrow like that, like, and that is equal to. It's equal to what? 3, 4. 3 minus 0 is 3. And 4 minus 0 is 4. So the vector is, the components are 3, 4. So the first one is that you're going in the x direction, left and right, left or right. If it's positive, it's because you're going to the right. If it's negative, you're going to the left. And 4 is that you're going either up or down, and it's a positive, so you're going up. So these are the components of the vector. This is the x component, and this is the y component of the vector. Sometimes they like saying it like this, a linear combination form of a vector. It's just a different way of saying the same thing. So this should be the same as this. So the vector is how much are you moving in the x, which is the I, in the I direction, which is x to the horizontal, and the j is the up and down. So you're moving 3 units on the I direction, and then 4 on the j. And what is the magnitude of the vector? Is the actual length of the vector. So you can tell me what is the magnitude of the vector. Let's see. A wild guess, anybody? Nobody's gonna guess. What's the length of the vector? Huh? 5. Thank you. 5. It's a 3, 4, 5 triangle, yes? It's a 3, 4, 5 triangle. Here's the formula. All right. So the magnitude of the vector is this formula here. You say the absolute value of v, of vector v, is equal to the square root of x squared plus y squared, which if you plug them in and work them out, it'll be 3 squared is 9 plus 16, 25. Square root of 25 is 5. All right, next. A component form of I guess we're gonna do some problems now. So you notice it has direction. It's going in the southeast direction. So component form of a vector. Say this vector started at negative 3, 2. And the terminal point is at 4, negative 1. Let's find the component form of the vector. In the first form, what was it? The first one called let's see. What did I say? It was 2 forms, no? Linear combination, and then what was the other one? This guy in the notes. What's the first one called? Just said component form of vector. Yeah. Okay. I don't know. Let's go. Let's go with the one where it just with this form. This one like that. Yeah. And then like that. Let's see. What should go here? Or should we do all the work? Let's see. What's the answer? What goes here? What's the x? Huh? If you work it all out, what would it be? All right, let's actually work it out. See, what we're doing is this. Let's go step by step, bro. Yeah. Let's do this. The formula says x2 minus x1. That's what it says. And then this one is going to be y2 minus y1. All right, let's go. Let's just do it. So if this is point 1, this is x1, y1. This is point 2, x2, y2.
Attention teachers, at this time, Rally A, make your way to the gym. As a reminder, the rotation has flipped as Mr. Serta had mentioned. Again, Rally A, make your way to the gym.
So what is it? What do we write down? 4 what? Minus what? A negative 3. And then it's going to be negative 1. Take negative 1 minus 2. You see? So you got to be really careful with signs here. So the vector is going to, component form of the vector will be what? 7 and what? Negative 3. So if you had problems with adding positive and negative numbers, you better learn and better be good at it, because there's a lot of minuses of negatives and positives and all kinds of things like that from algebra 1. So So what it's saying is that you're going to the right by 7 and down 3. So you are going to the right 1, 2, 3, 4, 5, 6, 7, and you're going down 1, 2, 3. All right. If you wanted to do the other one, linear combination, I think that's what I said. Let's see. If you wanted to do linear combination form of a vector, it's basically these numbers. You're going 7 in the I direction and negative 3 on the J. And then the magnitude of the vector is the formula, no? The formula would be that the magnitude is the absolute value of the components of the vector, which you're gonna have to do get each one of these x and y, the x value, square it, plus the y value square and then square root it. So if you want to write down the formula, if you really wanted to do everything, I'll do everything, but you don't have to because we got everything here. But the actual formula is actually the distance formula from geometry. Is x2 minus x1 squared plus y2 minus y1 squared. And we already labeled them over there before. If we're going to do everything step by step. So we did 4 minus the negative 3, which is 7. 7 squared. This is going to be 7 squared plus. And then this y2 is negative 1 minus 2 is negative 3. It's going to be negative 3 squared. And this is going to be 49 plus 9, 58. Square root of 58. So the square root of 58, it has no perfect square numbers in it. So that would be, I think, the answer. It doesn't simplify anymore, unless you wanted to put it in a calculator and get an approximation of what it would be. Moving on. Let's go to number 3. What are equivalent vectors? Equivalent vectors have the same magnitude and the same direction. So basically, like if I have, like we were playing, you guys write this down. Go ahead and write this down, and we go back to the first one I've done. There was this vector going like this. It went 3 and then up 4. It went 3 and up 4, and so the vector it was 5 and whatever. So if it moves over 3 and then up 4, then you can have another vector somewhere else on the same flat surface going over 3 and up 4, and they are equivalent vectors. So this is here and then here's another one exactly the same, going the same, with the same magnitude, same direction. So show that the vector from R to S is equivalent to the vector from P to Q. So you can just do the magnitude of each vector, and if they're the same, then they are equivalent vectors. All right, so let's find the R to S. Sometimes we can go like this. Instead of putting V, you can say RS, vector RS. And then we can just do find the components of them. All right, what's the x component, Grover? Loud. Oh, come on, man. Do we need to be doing every word of the work? Yes. Do you? What? Aiden, what is it? Oh, okay. Let's do it. Let's do the word. Let's do the word. So the formula says. Let me put the colors. Let me put the colors. X2 minus x1, comma, y2 minus y1. The components. Let me even change the color. Let me change the color. It's really the slope formula. But they're not. It's not the slope. Well, you don't put it like a fraction or nothing. You just put the top goes first and the bottom of the fraction goes to the next. So you can see the colors. What are we doing? What's negative? What's negative 4 minus? Hold on, x2. So this is 0.1, maybe you want to call it? This is 0.2. So yeah, let's go step by step then. Our -1, because that's the x of 0.2. Yes? So -1 minus -1 minus what? -4. Y2 is 6 minus 2. So what's the answer now, Grover? For this, for the x? Huh? 3. Evelyn, what is it? Why? 4. Oh, look, it's 3, 4. What am I doing? Why is it always 3, 4 in my examples I've been doing? Let's do P to Q. Yeah, okay, so let's go step by step. Okay, P to Q, Q is P2.2 and then P is the first one, P1. So let's maintain that one. That direction matters. The second one is always going to be 2. So it's going to be what? What are the numbers that I put here? Anybody? Huh? Well, you're already doing it. I'm going to go step by step. 5 minus what? And then what? 3 minus -1? Five minus 2 is what? 3, and then what? What's the 3 minus the -1? So are they equivalent vectors, yes or no? Yes, when this is the same as this, then they are equivalent vectors. All right. Let's go. Head to tail form of adding, subtracting vectors. Vectors can be added or subtracted to create a new vector. All right. Say a vector goes like that. Say another vector goes like that. What is vector V added to vector W? How do you show it with vectors, with those rays? Basically, you just put it's head to tail. It's a head to tail. It's right here telling you head to tail form of additive vectors. So you could do it two ways. You could just get that vector, get the vector and just draw it right here. As best as I can draw it. It has to be going exactly, it's just grabbing that thing and putting it over here. So it has to be like that, no? So it's going, I can't even do it. See, it's messing up. Let me see if I can just, I'm going to draw here. All right, as best I can do it. So that is this. And I just grab the green one and put it at the tip of this yellow one. And there's the new vector. So the new vector is going to be this. The new vector is going to be this. That's it. That's V plus W. What's the answer to that? What would be the answer to that? Huh? Pretty much go like this. Look, if I go like this, I push against somebody like this, and that person pushes back with the same force back to me, we're gonna be at a stalemate. We're gonna be like, it's gonna be like this. There's no, they undo each other. So there's nothing there. There's no force. So if I go like this, and then somebody else comes in and then put this at the tip of the yellow one, so it'll go, and they undo each other, and so it becomes nothing. So if you have these two, and you wanted to add those two right there. So I don't know if anybody got a question. You say, would you get the same one if you do it in the do that one first and put the other one after, or do this and then put the other one after? It's the same answer. You will get the same. No, it doesn't matter which one you do first. So here it is. Which one do you want me to do first? Anybody? Do you want me to do yellow or green? Somebody. Yellow or green? Which one do I draw first? Huh? Yellow. So let's draw yellow. So I'm going to draw yellow. And then I'm going to draw the green at the tip of this one as best as I can draw it. Yeah, it's off. It's off. I got to draw it with the same direction. Let's say I'm doing it right, a little longer. There. So then the answer is going to be connect the first and then connect the very last one. And then, I got this cool thing. There's some people that just have such good understanding of this without having gone to school at all. Like this one, he's my sister's husband. He can just come make tools out of nothing. Like he's trying to fix something, he has no tools, and so he grabs two things He grabs like a wrench, he grabs something else. And so he creates even a bigger force by putting it together. Anyways, whatever. He understands this stuff without. So there's the. There's the answer. When you add these two. It's too many, too much. Let's do a couple more. Let's go with number 7. So what do you think is, maybe I haven't even talked about this, but you got some vector. What do you think? This is a scalar number. This is like a number that just like amplifies it. If it's 2, it just makes it, it just amplifies it. It doubles it. If it's 2, it doubles the length of it. If it's 3, triples the length of it. So of the vector. So if the vector is that, then it'll be 3 times as long. I mean, this one's 2 times as long. 1. Something like that, right? So this is 2v, vector v. And we're going to add to the tip half of vector w. So half of vector w would be this much. So this much. A little more. And then there's the answer right there. That's it. No, I don't want to do this one. I don't want to do that. Hold on. I don't want to do this. It's too much. Too much of the same. I don't want to do that. Too much of the same. Let's do one. Let's do this better. Let's not do 7, 8, 9. Let me, because it's too much of the same. I gotta get rid of this. Sometimes these go redundant. What if I wanted to do this? A better question. What if I wanted to do the minus half of v? Let's do that. Let's do this. Let's do this one instead. All right. So you guys do it by yourself or do it with the group. Talk to your partner. Let's see if you can come up with, I'm going to do it in a minute. You do it. What would be this? What do you think it's going to be the answer to that? You guys do it. Do it. You got everything, Aiden? All right, so you guys got W. Let me just, you got the W, whatever. Trying to draw the same. I can't same exactly over here. But you're gonna do. Don't pay attention to minus for right now. Let's do this. Half of B. So we're gonna do half of this other one here. This one, half of that one is gonna be this, no? Oh, different. Go back to this color. Yes or no? This just tells you to go the other way. So instead of going like this, that minus makes it go the opposite way that it came from, like that. So it changes direction. So instead of going that way, it's gonna go that way. So really, that's what we're gonna do here. So this is what we want. So at the tip of this, we're gonna go, and it's gonna go this way. So the final answer is still going to be this. Because there's more going that way than up. Let's continue on. Now this is getting repetitive here. We already did this. But let's go. Hey, let's go right now. But still, let's go. Let's do it. But this time, I'm going to go faster. All right, the x component of P to R, don't say anything. Let's go with Ulises. What is the x component going from P to R? Huh? I don't know. You don't put it in there. I don't know. Grover, what is it? The x component? 3 is correct. 3 is correct. Everybody, yes? Everybody, we did this and I slowed it down. I slowed it down. You because no, we got it. This is I slowed it down in the other one already. Yes or no? We talked about subtract the. It's like the slope formula. The x will go first. No. Actually, the top goes after because it's subtract the y's or subtract the x's. So actually, anyways, this one is gonna be Aiden. 2. Huh? 2 is correct. Yes. All right. Let's go with the next one. Okay, here we go. Yes, let's go. B. -2 times vector QS plus 1/2 of vector PR. All right. So, the way we're going to do this, let's go step by step on this one. Negative 2, not exactly step by step, but because we got to be able to do that quick. X component of vector from Q to S. Don't say anything. Diego. X component of vector from Q to S. Q to S, that's what this is. Vector going from Q to S. Negative 6? Yes. Natalie, what would be the Y component? What? Come on. Oh, hold on. My bad. I don't know. I was looking at the wrong one. You're right. Okay, plus. Don't we already have P to R? Don't we have it from over here? 3, 2. What do you think we're going to do here? Anybody, what do you think we're going to do here? So what do you think, Sayuri? It is kind of distributed property. You just, yeah. So it's going to be what? Anybody? What's the answer? 12 and what? Negative 6. And then also here, this is going to be 3/2 if you want to. And 1, no? When you're adding two vectors, you can add the X components and then add the Y components to make it one vector. So that's what we're going to do. Well, you can go ahead and do 3/2 is what in decimal? 1.5, no? So what's 1.5 plus 12 is, just to make it quick, it's 13.5, yes? And then what's going to be the Y component? Negative what? Negative 5? No, do we? I think that's it. I'm gonna finish with this. Let's go. And I don't even, if there's more, I'm gonna stop. I'm done. Let's just finish up with 11A. That's it. All right, so let vector U is that, and vector V is that. Find the following analytically and sketch a graph. So these three letters are the ones they use a lot for vectors. U, V, and W, main ones. So we got vector U, 4 times vector U plus half of vector V, add them up, and it'll create vector W. So what's the x component of this? Y is. So basically, you got some vector. You got some vector 2, -4. Let u equals that, v equals that. Find a sketch graph. So you got some vector u going. Let's do this one. Is going 2. Is going 1, 2 to the right, 2 to the right, and then down 4. 1, 2, 3, 4. So there's the vector u, and then vector v is going 1, 2, 3, 4 to the left, and up 1, 2, 3, 4, 5, 6. So this is. And so what are we doing? We're doing four of these. 4. So it's going to go 1, 2, 3, 4. They're supposed to be the same size. And then we're going to do add half of v. So you want to go just half of it. So then that one's going to go here. It's going to go back over here. And then the answer is going to be something like this. Because there's more going that way, so it's going to be from here to something like that. Let's see. Okay, I didn't even sketch it. All right, we're done. That's it.